Hi, my name is Andrew Scarlett from Minnetonka High School, and I'm here to present to you my research on the applications of a cross-spherical gear as a robotic wrist component. The current robot industry continually strives to improve wrist components of articulated robotic arms that take advantage of the mechanisms to create a robust and capable system of moving the output length 360 degrees. Although engineers have created RYP and RPR wrist components that maximize efficient movement, there are still some ways to decrease wasted energy input and increase torque at the same time. My project focuses on replicating the newly invented cross-spherical gear system, or CSG, by Abanix in South Korea, and testing it in different areas of applications, as well as finding its strengths and weaknesses. There will be three motions for the simple mechanism. First is the gearing motion by rotating the monopole gear, or MP gear, around the pitch axis. Next will be the coupling motion via the rolling axis of the MP gear. Finally, there's the sliding motion, which is caused by the basic sphere gear reacting to the changing MP gear. As we add a second structural axis to the basic sphere gear, the ball becomes a cross-spherical gear with a quadratural spherical tooth structure. The second structural axis is also controlled by an MP gear and a driving module. Both MP gears and driving modules will be able to fluidly create a superimposition of interactions. Both perpendicular driving molecules are independent in motion and identical in design. At this point in the research, I unfortunately am not done designing and building the mechanism. However, I'm expected to get it done in the next 3 weeks. The motors that are being used are 12-volt DC brushless planetary gear motors with a 51-to-1 reduction ratio. These motors have a max torque of 60 kg/cm and a low load speed of 95 RPM. Each motor will be equipped with an L298N driver, which will help control the precision and obtain measurements. From the drivers, it will be controlled all by an Arduino Uno with either a joystick control or input coordinates. This mechanism has multiple potential applications, such as prosthetics or industrial automation, which will be tested with the torque, energy, and time ratios. The model will have controllable motion and algorithmic outputs to achieve the most efficient movement to arrive at set inputs. The CSG mechanism will also be tested against industrial standards in performance and efficiency. Since the prototype isn't finished yet, data is still inconclusive. However, expectations show the CSG mechanism will provide acceptable amounts of torque and precision.